So I work for the Financial Times, and specifically a bit called FT Labs. Last year I gave a talk at Velocity about convincing your company to invest in web performance. And this year I want to talk about a type of performance that all companies are heavily invested in, and that is getting more stuff done faster. So I have to admit, I am on occasion the kind of grumpy manager who wants to know, why aren't we doing things faster? But at the same time, I'm also quite often the optimistic, hopelessly optimistic developer who thinks he's going to get everything done today. And I think in 15 years of working with web development, the thing that frustrates me most is just how long it takes to produce a really good web application. And actually, I think it takes longer today than it did when I first started working with the web in the late 90s. So why is that? Well, first of all, we have more formats to care about than we used to. This is some interesting data from the FT. Actually, my colleague Mark Barnes stole my thunder slightly on this because he included this same graph in his talk yesterday. But anyone who didn't go to his session, this should be new to you. So we have a morning and an evening spike during commute hours from mobile devices. And during the day, we have a fairly solid block of desktop traffic, and that's during the week. But at the weekend, you can see the desktop traffic almost completely disappears. And we become essentially a mobile-only site. So the year of mobile really has come and gone. And these days, we're dealing with a vast array of different devices, and each one is a first-class customer. We also care a lot more about usability than we used to. Alice Bartlett did a great talk at Front End London last month about some research that she and her colleagues at Government Digital Service had done into the usability of select elements on forms. And they found that it turns out users quite often have problems understanding and interacting with select elements and drop-downs. And that's despite the fact that as developers, it's very easy for us to implement those elements. But something Alice said really resonated with me, which was, we're not here to do easy things for people who are like us. And that's something I think that as a community we've increasingly taken on as a responsibility. We understand that even if something is harder, we should do it if it makes life easier for the users. Speaking of which, we also care a lot more about accessibility than we used to. Leah Veru did a fantastic talk earlier this year at jQuery UK called The Chromosome, in which she spent 45 minutes talking about color. And she's produced this tool, which I now use a lot, to check contrast ratios between text colors and background colors to verify that they are within the WCAG accessibility guidelines. Something I would never have conceived of doing when I started working in web development. And finally, the users themselves are just more demanding and more impatient than they used to be. Akamai does regular research into user expectations of web performance, and they found that in 2006, at the 50th percentile, users were willing to wait around 4 seconds for a page loaded on an e-commerce site. In 2009, that was down to 2 seconds. So users are more demanding, more impatient. So generally speaking, the message here is that the quality bar is increasing. And as the quality bar increases, we have to find ways to maintain and even improve our development velocity. So at the FT, part of the solution to that is componentization. Now, using predefined, prefabricated components is hardly a new concept in software engineering, but it's actually fairly new to web development. If we look at some figures from, say, NPM, the number of packages in that community has more than doubled since the last Velocity EU, and the number of monthly downloads has more than trebled. So a lot of these back-end technology communities, whether it's Node or PHP or Python or Ruby, all seem to be coalescing around the idea of fairly strict package management for managing shared dependencies and modules. On the front end, though, the situation is far more vague. There isn't really a single best practice that front-end developers are coalescing around to manage front-end components. The first step in any kind of standardization of style can often still be the sort of static style guide. And this is one of my favorites. This is the signs manual for the London Underground. 220 pages that tells you everything you could possibly want to know about creating a sign or a map for the tube. And this works actually really well for the tube. It's a great solution for that use case. But it doesn't work for the web. Anna Debenham has a good curation of living style guides for the web. And this, if you look at it, look through it, you get really a clear idea of exactly how much variety there is in the way that people implement living style guides. There really is no one way that everyone has agreed on. So you get things like this, which are great examples of very simple, effective style guides for single sites. This is the South Tees Hospitals NHS Trust, and they've created a single static HTML page that simply has one example of every single thing in their style sheet. And that works really well for one team managing one site with one set of components that are only used on that one site. It doesn't work so well when you have multiple teams building lots of products that share the same components, where maybe one team is building components and another team is consuming them. Maybe one team is building components on top of another team's components. You need something that scales a bit better. So I came across the Lonely Planet approach, which is interesting. They've taken all their components and moved them into a separate project, which then becomes a component that can be required into all their individual applications. There's also a front end that you can go to look at what components are available. So looking through this, I can pick out a component, and then I can get some code. In this case, it's Ruby, that I can write into my application to fetch the HTML, the fully templated HTML for that component. And so the advantage of something like this is that I can use the same components in lots of projects, and also there is only one source of truth for the HTML. Because we're not copying and pasting the HTML, it can't get out of sync. So it is only ever updated in one place. The disadvantage is that it ties you to a particular back-end technology. It's very opinionated about how you create your applications. And that's something that didn't really work for us at the FT because we work with a lot of third parties, and they create apps for us in lots of different technologies. But nevertheless, this is a really exciting kind of step forward in the evolution of front-end components. And Ian Feather, who came up with it, did a talk at Front-End Ops earlier this year, which is also well worth a watch. So at the FT, we thought about all of this, and we came up with our own solution. And we call it Origami. And Origami takes the principle of abstracting components away from the application further by making every single component an individual project. So it has its own tests, documentation, demos, and most importantly, it has its own package management as well, or package configuration. So that means we can create dependency trees of components like this. So we have our forms component that contains all our radios and selects and text fields and so on. And that depends on icons, assets, buttons, typography, colors, and fonts. So this already seems like a fairly complex arrangement of components, and it encourages us to break components into smaller and smaller primitives. That means we end up with a lot of components. So we need tooling to try and support this. So we've created a component registry, and this registry auto-populates itself by crawling all of our code repositories. Whenever it comes across something that looks like an Origami component, it will generate documentation and demos. So this is the page on the forms component, so you can see demos of text fields, regular, disabled, selected, focused, and so on. And I can actually click a button in the top right-hand corner of any demo and get a JS bin pre-populated with that demo that I can then play around with like a kind of experimental playground. This, we found, is amazing for designers, product managers, non-native coders who, whilst they can't write the component themselves from scratch, they are quite adept at fiddling around with it, seeing how it behaves, experimenting with different states, understanding how the component reacts to interaction, seeing how it reacts to browser resizing, seeing how it sits on the page with other components. All of those things are really hard to do with mockups, but very easy to do when you have something like this, where you can just play around with the code and see how it affects the component. But you might be thinking, how do you get the forms component to work in JSBin? Because there were, like half a dozen components there, and they all had to be built together through some kind of build process to enable us to have one single CSS file that we can link in JSBin and make this look right. And the answer to that is we have built a build-on-demand service. So you can make a request to a URL starting build.origami.ft.com, pass the names of the modules that you want. The service will then install those modules locally to itself, install all their dependencies, run the standard build process, minify the CSS output, gzip it, cache it, serve it to you through a CDN. And I really can't overstate how easy that makes it to get started with our component system. We actually discovered that our Salesforce developers, who don't work on web at all, they build our internal business applications, have discovered Origami and used it to improve the UI of our Salesforce apps. And that's pretty incredible because we didn't tell them how to use it or anything. So we think we have here, what for us at the moment anyway, multiple caveats, is the ultimate front-end component system. Separation of those components into separate repos gives us a fully decentralized approach. Multiple teams can work together without blocking one another. The registry auto-discovering the components means we know that the registry is always comprehensive and always up to date. The standard build process means that any developer looking at any component will find it familiar, and there will be no kind of gotchas that come from individual developers kind of doing their own thing. And the build-on-demand service means that anyone can get started with this incredibly quickly, whether they be an internal in-house FT developer or whether they be an agency or a partner that we're working with. We can only go so far, though, with components. We can extract a lot of complexity out of the process of building products using components, but there's still complexity in products that we think we can extract. And to do that, we've also built some services. So we've built a lot of services, but I'm just going to touch on two of them today that I'm particularly excited about. The first one is a responsive images service. So we found that a lot of our products incorporate dynamic image resizing as part of what they need to do. So we took that functionality and we put it into a service. We also tried to build as much on top of that service as possible so that individual products don't need to build their own layers on top of the service. It comes kind of ready to go. It does exactly what you need. One thing we would love to build into the service, which we haven't yet, is image optimization, advanced image optimizations. My colleague, Cornel Lozinski, will be giving a talk, I think in this room, in a couple of hours' time, about lossy compression of PNGs, which is pretty incredible stuff. You might be thinking PNG is a lossless format. It was, and then Cornel invented a lossy encoder for PNG. So that's well worth sticking around for. The other service which I'm really excited about is our Polyfills service. So this is a requirement which really comes about as a result of componentizing your UI. You imagine you have 3 components on the page. Each of them requires class list, and none of them makes any assumptions about what else might be on the page. So they all ship with their own polyfill for class list. And then you load the page in IE11, which has class list. So you've just shipped 3 copies of a polyfill to a browser that doesn't need it anyway. There are other problems with polyfills as well. You might not know that you need one. You look at your site in a legacy browser, it looks broken, you don't know why. You might not know which one to use. Let's say you know that you need a class list polyfill, so you go to Google and you Google class list polyfill, and you get 7 of them. So which one do you use? So we built a service to try and address these problems and make this kind of thing easier. You put this script tag into your code before your own JavaScript. It will make a request to the Polyfill service, which will analyze the user agent of the user's browser, work out what polyfills are appropriate for that browser, package them, minify them, and serve them back to you. We have a feature matrix on the site that tells you which features we support, which browsers we support them in. It will tell you which browsers support those features natively and which browsers we can polyfill. Some we just can't polyfill at all, so you'll also see grey boxes for those. And we publish our uptime and performance data, so you can get a really good idea of what effect putting the polyfill service will have on the performance of your site. So we think we've covered a lot of bases here. We've tried to build a platform for everyone. We minify and gzip the responses. We support HTTPS. We support best practice caching both at the CDN and at the browser level, including the new stale while revalidate HTTP extension. We have a really comprehensive test suite. All of the polyfills in the polyfill service have tests, or most of them do. And when we push, every time we push, we run those tests on 26 browsers. We have permissive cause headers, so you can use the service from Ajax if you want to. We publish those uptime and performance metrics, and because it's open source, you can run it as a service yourself. Or if you like, you can even use it as a node module. So if your application is actually written in Node, then you can just get that polyfill behavior as part of your own application. So as I said, we think we've built a really good, solid foundation of a platform. And we also have a fairly good starting set of polyfills. But this is a mammoth project, and we really want to get everybody involved in it so that we can build a resource which is really for everyone in the community. So to try and encourage that, we're currently offering a month of free premium access to all FT content for anyone who merges a pull request in this repository. It can be anything from contributing a new polyfill to correcting a typo in our documentation. So if you use polyfills in your projects, I'm sure most people do, or maybe you maintain one, please go and check out cdn.polyfill.io when you get a chance and try it on your own site, give us some feedback, contribute some polyfills or maybe fix some bugs. And not only will you be making a service that it enhances everyone's ability to use modern web APIs, but you'll also allow everyone to get this benefit from extracting complexity from the process of building apps into components and services, which I think is the future of web development. So enjoy day 2. Thank you very much.